So you have to open the ETABS file and ensure that this model has been logged. Model has been logged, it means that the analysis has been completed and the calculation has been done. So it would log. So to make the analysis complete, you need to click on run analysis. And you can notice that all these icons, like which I used to build the model, that becomes grayed. That doesn't get highlighted. And now we can ensure that the model has been logged. The next step is you need to export this particular inputs into the save file. So how do you use that is like file and export and story as save B2K file and story base, that is the base of the columns, and export floor loads and from above because you need to export the above loads as well. Select load case all, select load combination also all because you need both the load combinations and okay. And here you'll mention as uh, Dinesh save F2K file. I'm saying it as F2K because it's a F2K file format. So now you'll open save and okay. Now you'll go here, file, import, save F2K file and import like this. Now you'll have to verify whether whatever what you have imported is the same as your ETABS model, right? So you will keep this side by side. So how you verify is, see here, if you want to view the columns, what you do, you have to turn on the, you can click on this and you will be able to see the columns. You need to go to the base level. This is the base. And here you can click on display support reactions. And here, see B grid, right click, and you'll be able to see the loads. And here it shows the load pattern separately, like dead, live, and super dead separately. So it should not be in combos. You should can go in case. If you click on case and click OK, then you will get, see, 151 for this. How much are we having? And see here, 151. And the next one, 238. So this is validated. So next what we will do, we'll see whether the live loads have come properly and in FZ direction. Because Fx and Fy are not going to have any much impact because we are not designing this for lateral load. We are just defining it for gravity loss. So let us check here. E2. 242. 242. So it is correct. Similarly, you can see for the another load case, which is super dead. And let me check it here. How much the value should be? 1B. 1B. See 555. Super dead. So it's okay. So we'll now click on joints, points, visible. Let's make it so that these are visible and we have to draw the columns. But before drawing columns, we need to define the software as what are the materials we are using. So we'll go to define and materials, and here you can either edit it or do add new property material. This is M20, M20 you'll put. So this is 23 kilonewton per meter cube. That's fine. M20. And modulus of elasticity is calculated by 5000 root FCK, which is 5000 root 20. The value is 22,360. You need to update here. And what you're doing 20. So compressor strength is 20. So okay. Then add new material. Now you are going rebar. Rebar is nothing but that Fe 500 bars. Fe 500. This is correct. This is correct. Here, tensile stress, minimum tensile stress. That's okay. Actually, it should be 500, but let's put it less itself. That's fine. Not 500 only. So two materials have been defined. And next, what you'll define? You'll define the slab properties. Add new property. Slab is first is 12 inches, 300. This should be properly selected. M20 it should be made because that's a slab, right? Footing is nothing but a slab. So you need to put it as slab. You can delete off whichever is not necessary. You can delete them. Oh, I think you can't delete the default materials. Anyways, define column. What all columns you have in this particular project, you can define those. So what are we having? We are having 150 by 450, parallel to two axes is 450, parallel to one is 150. Oh no. See here, this is very, very important. You should change this. See, then add copy of property so that all the details will be same and there wouldn't be any mistakes. 150 by 600. Change the colors. What are the other sizes which you have? 230 by 600. Then okay. Soil subgrade properties is very important. What it is soil subgrade is nothing but your SBC of the soil. In this project, it is 180. So 180 divided by how much the soil can settle. We can settle up to like 50 of settlement is okay. 0.05. It's like 3,600. 3,600. Subgrade modulus 180 divided by 0.05. Okay. Now we have defined everything. See, all these things. One is materials and flap properties, column properties, and soil subgrade properties. These four things after you define this thing, this. After you define these four things, there is nothing more to do over here. Now you need to start modeling it as per what is there in as per what is there in ETABS, you need to start modeling it. So what will you model first? You will have to model the columns. Only then you will be able to Only then you'll be able to next draw the footing of your assumed size and check whether that is sufficient or not. So which column you'll draw here? 150 by 450. See, this is coming as horizontal. You need it as vertical column. It's like a vertical column. The same thing you're going to remodel it on ETABS. Safe. So make this as angle as 90 degree and height above is 3 meters. Height above 3 meters until your next plinth or something. Sorry, height below is 0. Height above is 3 meters. Plan offset X by and all nothing. Property below is none because there is nothing below. It's like soil. Property above is none. We'll go on to place the columns. We'll place it like this, place it like this, place it like this, here, here. But be very careful where you're placing. Double check what you're placing also. See, this dimension doesn't seem to be appropriate for me. Let me check the column properties again. Okay, it's correct one. G6, D4, E2. So now you are done with the placing of columns. Next, you would have assumed, okay, this should be the proper size. This would be the proper size for the footings, right? So open that CAD file and make the measurements here. You need to redraw it here. Now, next we have to select a line like this. See, here you'll select a line. This is like a reference line you are going to use in order to draw your slabs. Here you put this none. This should be very carefully done. This should be done. And here, if you are having this meters, no, for your convenience, change it to feet because it is not easy and change it to feet for some time. And again, you can bring it back to SI units. Now it's in feet. So it is more easy and convenient for you to mark the measurements. So we'll show it as an example for one particular column. So one footing I will show. Similarly, you should do for all the footings over here. I'm just measuring the sizes. 1 minute. See, this is the main footings for which has to be recreated. I will take the measurements. This is 15 and a half by this. Mainly grid measurements. Why we take grids? Grids are taken such that how much distance this particular lines are there, outermost boundaries are there from your existing grid lines. Because we have grids. Same way at site also they will be doing. This one I have to recreate. So these measurements are enough, no, for me. From this line, from fourth grid, it is 3 feet 1. From 4th feet towards down, it is 12 feet. Fourth, grid number 4, here, it is 3 feet 1 inch. 4th feet. You say I should draw from this side. Because towards up. Okay. Select again 4 feet. Sorry, 3 feet 1. 3 feet. It's directly drawing on it. Okay, let's do for the higher dimensions. Drawing there. Beautiful. It drew here. So here for 4 feet or 3 feet, the draw it comes here. And along the vertical, it is 5 feet 3 from this particular corner. See, plan offset, whatever you're typing, ensure that that is being drawn. 5 feet. Oh, it is not able to understand 5 feet 3 and 5.25. Not towards the right, should be towards the left. So right click at that time. You do right click, so it will go off. Oh, it is going beyond see, going beyond the line means delete this off and ensure that this is the point. We are at the side boundary. This itself you consider as the point. And over here, what is this? 10.25. So you got one particular like grid lines or something like a helping line. So you'll click on slab and draw slab now. See, you got 4 different points, you got slab. And now what you'll do, delete these lines. After you draw once for everything and once you're completely sure and things like that, and you will delete this line because these lines are not necessary and not going to participate in anything. Just for you to draw the slab, we have created this. So what you got to do now is select properties, beam properties, none. See, observe here, it is ready now. And once you do this, 3 lines are selected. Delete those 3 lines. So those 3 lines are deleted. Now what you got to do, you need to apply soil property. See, this is the property thinks that it is slab, but it has soil property, right? So assign, suppose once you have done with all things, once you have done with all the slabs, select all the slabs one by one like this. Assign, see, select the slab, assign support data, soil properties, and apply this. Then only this particular slab becomes rested on the soil and it has that support also. Now what we have to do is we have to draw strips. See, yes, strips are here. Draw design strips. And that one you'll draw. See, that one has to be drawn in intervals of 1 meter. So now again you go here, convert this back to metric defaults. Because you no longer need the feeds because now it is based on meters. Whatever design we do for slabs, it is based on for unit length. So consider that strip A is along X direction and you'll draw like this. Somewhere here you'll draw. And consider B is Y direction and you'll draw something like this. Now you have drawn X and Y thing. Now for your ease, like here you can click show strip width, show width. It will look more appealing to you. But this is the line where it is going to cut. This is 1 meter. So this you need to put it across this length. Linear dx, sorry, dy this is because you have selected this one. It should be moving towards y, 1 meter. Number of increments will make it as 6. Some number you give. Oh no, it should have been -1. Here control R doesn't work. How you go is edit or replicate works. Okay. Here -1. These many are not required. Delete the things which are not necessary. Anything going beyond the box is not required, right? Initially itself try to give as low as possible. If required, you can increase because here it will leave off this particular dots. Dx is 1. Along increment, you can put it like 4 and see. See, I think you require one more. Now this is okay. Now you will save this and now you will run analysis. See, all the properties have been defined. And here, mainly you should go here. Sorry. Design preferences. See, this is an ACI, American code. We require an Indian code. Minimum cover for slabs is, these are okay. Minimum cover for beams, okay. This is okay. And design combos. See, we are designing for factor load combination, FOS 1.5. So this is okay. Cross verify this before you run the analysis. And display detailing preference, like how you require this detailing to be done. Okay. Slab mat reinforcement preference. Here, rebar selection. Use minimum reinforcement. See, some places reinforcement wouldn't be required, but as per code, it is 0.12%. Minimum that much should be there. Smallest bar, let it be 8 mm. Largest bar, clear. Click OK. So now you are done. These are fine. These are fine. Now you'll run analysis. See, the first thing to check when you run this analysis is you need to check for punching shear. Here, there's an option, show punching shear design. If it is more than one, then the particular column is going to like pierce and go off inside. See, this is going to fail. This is going to fail. This is going to fail. Then immediately what you need to do is increase the slab thickness. You need to increase the thickness of this particular slab. See here, because this two columns are getting very low loads. It's only 20 tons, 20 tons. This is crossing like 100. This is crossing 100. So this is not sufficient. This 12 inches what slab we are given is not sufficient. Now we'll see design step is no longer needed for us now, as of now. Or you can just remove the show bit. You need to change the slab thickness. Add copy of property, slab, multiples of 3. 15 inches means it is 300 plus 75, 375. Add copy of property. Slab, 18 inches. Add copy of property. Slab, 21 inches. See, with my practice, I know that this particular thing is going to take many iterations. You can try from next, and finally arrive at one. So if my slab 24 is going to satisfy, slab 24 is there. There also you can check. See, rebar material is not properly selected. That is also more important. You should select FE500. See here, you should go here and select. Just like how we define for other things, slab design overrides, finite element based, and FE500. Now we will check the punching shear. See, it has come under control, but even now it is not, it is in border level. So 26 inches, 24 inches is not sufficient. Make it 27. Because border level, let's not leave it because there will be some problems occurring at site or we can't decide like things too can happen. Always be on safer side. So now when you check the punching shear, it is below 1. So first check is over. So the next check what we are doing is, see, I'll list down the list of checks. List of checks. First is punching shear. Next is show deform shape. See here, you have an option, show deform shape. This triangle icon. Or else, if you are not able to find it there, you can click here, display, show deform shape. Here, see, you are seeing for load combination this factor of which factor of it. This, how much you are getting? Oh, it's like huge. It's like you have assumed only 50 mm, but here you are getting so much of. Oh, no, no, no. It is like below. It is being lifted up. So this is okay. So this is fine actually. You are somewhere here and all, no? Like 80, this 80 and all. Then it would be a problem. It has been supported well because of the slab thickness. Show deformed shape is fine. Show reaction forces. Load combination. This you'll select. Soil pressure. Third is show reaction forces. You will select that option. Soil pressure. See, display, show reaction forces, soil pressure. Type of reaction is soil pressure. These all are fine. If I had, okay, let me take this in. Choose this as 15 inches or something so that you know the difference, what happens. Here, what you'll do, you will first see punching shear. It is failing. Okay, in the failing case, what happens for deformed shape? Deformed shape is more, oh, sometimes this is like this only. Then now what you'll do next is third check is over. This scenario, it has come like this, but for oh, okay, okay, okay. This and all reaction forces and all should be checked for okay, even then see checks are done for unfactored load combination, but seems that the size of it has to be increased some more. The 1 feet extra if you put here, the main it is causing a lot of trouble, right? Like our soil safeguarding capacity is 180, but it is becoming like 234 and things like that. Increase size of footing by 1 feet. 1 feet, 1 feet on either sides, then it will reduce. We'll see in that. Yeah, I'll put like control you 2 feet. I'll increase on either sides. So now I'll delete the slab. I will put this slab. First, let me draw. And after that, I'll delete the previous slab. Control you. Fine here. So slab 18 inches you'll put and we'll see the, yep. Oh, oh. See, we have not applied the soils upgrade. For that reason, there's no support and soil is like terribly failing. The soils upgrade is not applied. Soil property none. See the impact of soil. If suppose you are building on air, this soil and all, this particular slab will fail because it's like huge, tremendous load which is coming. Now see, it's within the permissible limit. Previously, what are the problem? The problem was we had not, we had to increase the size. Increasing the size and increasing the depth should happen proportionately. People will comment for both. Like they'll say size is too high, but you can't do anything because you need to try to bring down steel also. Concrete is more cheaper. And what next you'll check? You'll check this reaction forces. See, reaction forces are within permissible. 180 is the soil strength. So it is within 180, right? Everywhere. So what did we learn? We learned that it has to be in load combination. We are checking for load combination without factor of safety. And this should be within 50, this deflection. And to achieve that, we can either increase the size of the footing. If it is not possible, then increase the depth. I increase now by 2 feet. Increase by 2 feet. Now it is satisfying, but not fully because punching shear still it's failing. But these three design sets are okay now. Only punching shear has to be improved. That we can do. Now just see show slab slip forces. These are the forces which are coming along these lines, and that has to be designed by detailing. So slab design here you'll put it as layer A, layer B. You'll be checking parallelly. Reinforcement. You need to write down what you see. See 8 bar when you are bracing at see minimum spacing is 200 Only for combined footing will provide top bars. I will say here, see, only show me top bar whether it is required. See, top bar in this direction is not required. In this direction also top bar is not required. I will say show both. See, top bar, if I'm like spacing like 20,000 means it's not, it's like placing nothing. In that case, it is telling me to provide at some places. So we'll put a top bar to be on safer side. 8 at 200 is around very nominal. 8 at 200 is very nominal. We'll next focus on bottom bar. Bottom bar, see 900 and all it is asking. It requires 900 square per meter. So you can't go with 8. You can either reduce 8's spacing, 150, then it will say it is requiring still more. 100, maximum is 150. 100 and all, it is like 4 inches spacing is difficult that side. So go to 10 also, it won't be possible. It will show like this only. 12 if you show also. See, this is all exceedingly high. So we'll put 12 at 100. And in between, we will increase the, see, this will be the default. I will write down this, but still, this is not correct because this is not accurate. Still, it requires more fine tuning because it's very high. Here it is increasing, here it is increasing. You'll see in layer B. For layer B also, it is having more trouble. We have to put a beam here. We'll put a beam and see. Before that, we correct punching shear problem. See, if we increase the size also, previously you are getting, no, this is okay. Other things and all will be fine. Click on this. See, as you increase the size, the bar requirement also reduces. These all are fine. We'll put one beam here, 27 inch, right? So we'll put it like a combined footing. Define beam properties. Define beam properties. Beam 20, 500. Beam width at top. It is 30. What is 27? 675. Now we are putting beam 230x 675. We'll draw it here. Once you put this beam, what happens? It is going to carry a load and it is going to reduce everything significantly. Punching shear is not applicable at all. It's so less. Grip forces also it becomes very less. Now you can increase this also. Or you can make it 200. 200 is also fine. No, 200 is not possible. 12 at 100 only let it be. Here the column junction it shows more. Okay, let's see the beam design. The beam it is telling top bars you need more. Here it should be enveloping. Enveloping means it's like flexure and tension design. Both together it'll check and tell. See, these are critical points. 796. bottom, top 291. See, in beams for footing, it will behave exactly opposite to our regular beams. Usually in center, we will have the uh, bottom bar. Center will be having bottom bars. Top will be having corner bars. But here it is like ulta beam. The beam you will putting beam and drawing the beam on sheet. Next, ask for shear 721. So now we'll calculate how much is this? How many bars of steel is required? Where are we going to do that? 720, right? 720 steel required per mm square, 770. Bar dias 8 mm, 2 leg spacing. Okay. Then like 770, 10 mm, 2 leg 10 T at 8 inches. 2 leg 10 T at 8 inches. Then what about what about longitudinal bar? Apply. How do you find out that is? You need 796C. Here top bar 291 we have to achieve. 291 can be achieved by 2T16. Entire length only it is telling. Center only it is 291. So make it 2T12. Center 2T12. 2T12. Next the bottom how it is. It is like fully it is less only. Bottom it is 2T16. Oh sorry. You need 796, right? 2T16 and 2T16. Where entirely it will be 2T16 and this also will be 2T6. So this is a beam which you are putting. So this is the design. Design has been completed. Now, what design you got? Size is size of the footing is 17 feet, 18 by 17 and a half. How you do here? You need cross checking now. Bottom bar 12 at 8 is 12 at 4. 21. requiring more here and all. So 12 at, see, if you put 16, it'll, nothing is required. So this and all is very minimum, so it is fine. Software calculates by inch. In reality, there will be some contribution done by the remaining part also on here. So 12 at 4, top is 8 at 8. So do for remaining all the beams and find out the exact values of the dimensions which has to be provided. Now Fi is this one. There will be a small gap between the both the puttings as per the as per CAD. Small gap is there. Similarly, you also provide a small gap. F6 also same. F6 I will do and show once now. Okay, we'll draw this F6 and see. Showing, see, I will select the beam line. Here I'll put none because this beam I'm not going to use it here. It is like 2 feet 3. See, I'll again change the units. Click on this again. 2.3. What is 2.3? It's on the right. 5.75. Eight point seven five. Video. Now you got 3 points you can directly draw. So here you need one more point. 1.25. So you draw that. Similarly for this one. So now you'll select all the Select properties, slab properties. I mean, select, select properties, beam properties, none, delete them. Now you will select, see, similarly, select slab properties. Since you have given both as 18 inches, two will be selected. Assign support data, soil properties. Yes. And now you will draw. Now you again you go back to SI unit. We will draw strip lines now. Column step. First, A is horizontal. B is vertical. See, you can notice here two design steps are selected. Based on that, you create -1 from if I you create, it's created. Delete the excess things. Control R. Don't give more also. See, you can't delete this later. Oh, you can delete it. We delete unnecessary things. Now do analysis. Lab punching share not satisfied. So it also has more. Uh, it requires 27 benches. Oh, oh, even then it is not satisfying. 30 years. Uh, always, all these things we should have it as see slabs. We will select properties, slab properties. Actually, all slabs will select. Ensure that see three areas are selected and assign slab data properties. Where is that? Previously, I showed no once. How you will provide for slab. This thing, what is it? Slab design overrides finite element based method. It should be FE500. F500 is what we are using. Let's check again. This is okay. 30 inches is okay. 33 is too high. 30 itself they will comment. Okay, next. There, the sizes actually we can increase. See here and all, it is failing very badly, so we can only produce pedestals. But if we are increasing this also, it wouldn't be satisfying because this is an eccentric column footing, right? So it requires pedestal. It requires pedestal, and when we put pedestal, it will satisfy. So pedestal, we are not modeling and sticking here. We don't have that option. Display. See, this place it is going to fail because it is too much. It's center of footing should always match the center of column, but here it is not possible. And never provide top bars. Let's put a beam and see. Providing a beam is not that effective. Instead, providing a column would be great. This one, providing don't provide a beam. Provide. So this is how you do the design, and you try to optimize things and get the best values. And each time when you get the values for each separate footing, you need to write down, because this footing specification which you are going to specify here is going to be applied for the entire all the footings in this particular page. It is actually not required, right? You will be losing out on the data. See, for this one, if I have not written down, I don't know what it was earlier, what I had finalized on. Because I've written down, I know. Okay, fine. Try to put a pedestal and see. No? Pedestal is nothing but height above will be half 1.5, and column dimension is see define column properties. We are going to provide it as a square. Suppose it is 600, we are going to enhance it 150 on both sides. So if it is 600, then it will be dimension will be 13. So I can make it as add copy of property pedestal 750 x 750 pedestal. Okay, pedestal. See, at the point where there is pedestal, there is no kind of impact, no problems created. Oh, bottom bar. See, bottom we have 12 at 16 at 8. Majority of things are satisfied. Majorly dissatisfied. Top bar is not required. See, I will show again. Then these are the values, right? So let's take a screenshot with pedestal. So now let's remove this pedestal. I'll go select properties, column properties, and delete it. Two lines are selected, delete. Now I'll cross check. Oh, applying pedestal is causing no problem. Okay, you need to do like this for all the particular footings, and then we can verify the values.